you gave this practice, want to try with the stopper, going around in a circle on the end of a 0.85 meters string. They tell you the mass is 65 grams and they tell you it's going at 2 revolutions per second. So the first thing you need to do is realize, what is this 2 revolutions per second telling you? So it's actually telling us the frequency. Now, some of you might have saw 2 revolutions per second and said that sounds like angular velocity, which if it went 2 revolutions per second, I got to put that into radians per second. And so this would be 4 pi radians per second would be my omega. And when we're dealing with constant angular velocity, frequency and angular velocity are the same thing. If we're dealing with something where it's speeding up or slowing down, frequency isn't even a term we use. Okay? So for part A, the first thing you were asked to do is find the period. So the period is the inverse of the frequency. And so in this case, we end up with 1/2 or 0.5 seconds. Now you might have been able to just kind of think through that in your head, that if it goes around 2 times in 1 second, well, it's going to go around 1 time in 1/2 a second. That's fine. The second part says, what is the radial acceleration of that stopper? Okay, so for part B, now you're trying to find that AC value, and you have 2 options available to you. You can do V squared over R, or you can do omega squared times R. I'm going to choose the omega squared times R, simply because I just need to change the units and I have my omega. Either way is fine. If you wanted to do it a different way, you wanted to say, well, I can find omega because it's 2 pi divided by the period and plug that in, or I wanted to say V was equal to 2 pi R divided by the period, that's fine too. There's multiple ways to get there. Plug in that information and you should end up with the centripetal acceleration. So if I plug in my 4 pi quantity, square it, and then multiply by my radius, my 0.85, you should be getting 134 meters per second squared. And just as a quick reminder, if you do see something that's a Greek letter, theta, omega, alpha, those are going to be the ones where it's radians, radians per second squared. And since this is just our regular old A, our Roman letter A, we're going to get meters per second squared. Okay. Part C wants us to find the tension at the top. So just like we did for our little review video right before this, we're going to want to go ahead and draw our free body diagram for this point up at the top. So I have gravity acting on it. I also have tension acting on it along the string away from the object. I also need to identify the direction of AC, label that as positive. Now to generate my equation, the sum of the forces parallel to the radius, set it equal to MAC. I know what AC is, I know what the mass is. I will have to, of course, convert this into kilograms. And so inside of here, there's mass and tension, and the tension is what I'm really looking for here. So we got both pointing in, so tension plus mg equals MAC. So the tension is going to be MAC minus mg. Go ahead, plug in your mass, 0.065, plug in your centripetal acceleration, your mass, 9.8. You should come out to a number like 8.09 newtons for a tension there. Part D wants you to find what is the angular velocity of the stopper. So what is omega? Well, we already found that, so that's pretty straightforward. If we hadn't found that already, maybe you would have chose the method of, omega is equal to 2 pi divided by the period, where you plug in your period of 0.5 seconds and you get that 4 pi number. We like to have that in more of a decimal format, so that comes out to 12.6 radians per second. And there's that practice problem you did.